All right, welcome. So if you're gearing up for the AZ-305, you already know that designing data storage is, well, it's a huge piece of the puzzle. But here's the secret. This exam isn't really about how you click the buttons. It's all about the why and the which. Why this service over that one? Which option truly nails the requirements?
Okay, so here's our game plan. We're going to dive right in, and I want you to put on your architect hat. We'll walk through the exact thought process, that mental checklist you'd run through when a new project lands on your desk. We'll kick things off with the absolute most important question, then figure out the right service, and finally, we'll layer in all the important stuff like durability, cost, and yeah, of course, security. So before you even think about clicking on a single Azure service, the most critical step, the absolute number one thing, is to just take a step back. You've got to define the problem you're actually trying to solve. Because really, every great design starts with asking great questions.
And this is it. This is the question, the big one. Seriously, the answer you get here is going to ripple through every single decision you make down the line. We're talking reliability, performance, all the way to that final price tag. Nailing this first step is basically the foundation for everything else. It's how you build something solid and, cost-effective. Right, so every single workload you architect, you should be running it through these 5 pillars. I like to think of it like a funnel, You start at the top, step 1, data type. Is it unstructured, like a video file? Boom, that immediately points you in one direction. Then you hit step 2, performance. Does it need crazy low latency? If the answer is yes, well, your list of options just got a lot shorter. See how that works? Each step just logically flows into the next, helping you zero in on that perfect solution. Okay, so now that we've got our requirements all laid out, we can finally start the fun part, matching them up with Azure's storage services. And this is really all about picking the right tool for the right job. Simple as that. So let's get into the specifics. When you see unstructured stuff, images, videos, log files, your brain should immediately go to Blob storage. That's its bread and butter. Now, if you're dealing with a classic lift and shift, like an old on-prem file share that speaks SMB, Azure Files is going to be your best friend. But, and this is a big but, if the scenario starts throwing around words like high performance, enterprise grade, and especially NFS workloads for Linux apps, well, that's a huge flashing sign pointing straight to Azure NetApp Files. This brings up a really key point that trips a lot of people up on the exam. Data Lake Storage Gen 2, it's not some totally separate brand new thing. Think of it as a super-powered version of Blob storage. It's actually just a set of capabilities you enable on top of a Blob account. So when you hear those magic words, big data analytics, Hadoop, or the need for a real folder structure to boost performance, that's your cue. You just flip the switch on the hierarchical namespace and bam, your Blob container is now a full-fledged data lake. Awesome. So we've picked our service, but we're not done yet. Now we have to figure out how to protect the data and how to manage the cost. And here's the thing about Azure. These two decisions, durability and cost, they are completely tied together. You almost can't talk about one without the other. Generally, the more durable you make it, the more it's going to cost. Okay, listen up, because the exam is definitely going to hit you with this. Let's break it down real simple. LRS, that's your cheapest option, but it's only going to save you if a single server rack goes down, not a whole building. For the really important stuff, the mission-critical workloads where an entire data center could go offline, you've got to have ZRS. Now, what if the business says, we can't be down even if the whole Azure region has a problem? Well, that's when you step up to geo-redundancy. And GZRS, that's like the ultimate insurance policy. It gives you protection against a data center failure in your main region, plus a full copy in a totally different region. It all comes down to that classic trade-off between cost and risk.
And this is how you get smart about managing the cost. I love this analogy. Think of it like a closet in your house. The hot tier, that's your favorite jacket hanging right by the door. It's super fast to grab, but it takes up that prime expensive real estate. Then you've got the archive tier. That's like that box of old college photos way up in the attic. It costs almost nothing to store it up there, but man, if you need it, it's going to take you a few hours to dig it out. So the trick is to use something called lifecycle management to automatically move that data down the pyramid as it gets older and you stop using it so much. It's a total game changer for your budget.
All right, let's talk security. This is non-negotiable, right? And it's never, ever just about flipping one switch. As an architect, you have to think in layers. like an onion. You've got to build a defense that starts way out at the network perimeter and goes all the way down to who has permission to touch a single file. So, the most important idea to grasp here is this separation between the control plane and the data plane. Let me break that down. The control plane is like being the building superintendent. You can change the locks on the building, that's like changing the redundancy settings. You can repaint the hallways, that's like adding tags. But you don't have the key to get inside any of the actual apartments. The data plane, that's the key to the apartment. It's all about who can actually get in and see the data. A super common exam scenario is giving an IT admin the contributor role so they can manage the storage account, but then giving an application a totally different role, like storage blob data reader, so it can access the files inside. This whole idea is called the principle of least privilege, and it is absolutely critical.
Okay, moving on. Let's be clear. Data storage isn't just about files and blobs. For the AZ-305, you absolutely, positively have to know how to pick the right database platform. And that means understanding the difference between relational and NoSQL and when to use each.
This right here is your classic IaaS versus PaaS showdown. And trust me, the exam loves to throw scenarios at you to test this. Here's the simple rule. If a company says they need total control, like they need to manage the operating system themselves, or they have some old app with weird configurations, then SQL on a VM is your answer. It's a lift and shift. But for pretty much any new, modern, cloud-native application where you just want to focus on the code and not the patching, a PaaS service like Azure SQL DB is going to be the smarter, more efficient choice almost every single time.
Now, if you're in the exam and you see certain keywords, I'm talking globally distributed, low latency reads and writes worldwide, or multi-model, a little alarm should go off in your head that just screams Cosmos DB. It's Azure's top-shelf NoSQL database, and it was purpose-built for those kinds of insane, high-demand scenarios. One of the big decisions you'll face is about consistency. Do you need strong consistency, where you guarantee that every user on the planet sees the exact same data at the exact same time, even if it's a tiny bit slower? Or is eventual consistency okay, where you trade that guarantee for blazing fast speed, knowing the data might be out of sync by a few milliseconds? That's a classic architectural trade-off.
All right, let's put all this theory into practice. Because honestly, the best way to get ready for this exam is to just run through some real-world scenarios. So let's do a couple of rapid-fire examples right now. Okay, read that one. What are the keywords that just jump off the page at you? For me, I see high performance, I see file share, and I see Linux, which immediately makes me think NFS. And then there's the big one. It must survive a data center failure.
So what's the answer? Well, that high-performance NFS requirement points us straight to one service, Azure NetApp files. And that survive a data center failure bit? That means we have to use Zone Redundant Storage, or ZRS. See, it's a perfect one-to-one mapping of the requirements to the solution. This is exactly the kind of logic you need to use on the exam.
All right, next one. Let's pull this apart. What do we have? We've got long-term retention, a full 7 years. We've got data that's rarely touched after year 1. And we have a specific retrieval window, 24 hours. To me, this just screams cost optimization. How do we store this cheaply but still meet the rules? And the solution here really highlights a critical point. Sometimes the answer isn't just one service. It's a service plus a feature. So we're not just going to say blob storage. We're going to say blob storage with a lifecycle management policy. That policy is what's going to automatically push that old data down to the super cheap archive tier. And that simple combo, it perfectly nails the balance between long-term retention and keeping costs way, way down. And there you have it. This last slide, this is basically your cheat sheet. This is your key takeaway. Seriously, burn these design rules into your brain. If you can look at an exam question and quickly map its requirements to one of these patterns, you're going to be in absolutely fantastic shape for any data storage question the AZ-305 throws at you. So look, mastering storage is a massive piece of the whole architect puzzle, but it's not the only piece. The next step is figuring out how to weave all this into a complete, secure, and resilient system. And that means bringing in networking, compute, all the other good stuff. So keep building on what you've learned. Good luck with your studies.